Well, welcome very much to the talk. My name is George Low. I'm a VP of Engineering at Marketo, and my colleague Jay New, Director of Engineering at Marketo. Today, we're going to share with you our experience of replacing one of a big legacy system with a reactive system, and some of the lessons that we have learned. So before we start, by show of hand, how many of you are in organizations that have completed successfully reactive systems to our customers? And how many of you are thinking about going reactive with your company? And great. So actually more people are thinking about that. And that's what we went through at the beginning of our journey. And more than 2 years ago, we actually started to realize our legacy system is not working very well. And we needed to replace with a system. But we didn't actually have much experience and knowledge about reactive or Akka. And that's actually why we went through a lot of challenges, and hopefully we can share some of the lessons with you, and maybe we'll give you some interesting information that will be useful for your journey as well. For those of you who actually have successfully completed it, please welcome to share your questions and feedback at the end at the Q&A session. So yesterday, our colleague already presented a lot of the deep technical knowledge about our reactive system. So today, we'll stay a little bit more higher level, but we will still get into some architecture for you guys. Okay, so before we started talking about our journey, just a few sentences about what Marketo is. Well, this is our official slogan. Marketo is a company that will bring you the engagement platform that will allow marketers, who are our customers, to create long-lasting relationship with their own customers in order to grow revenue. Now, obviously, this is marketing talk. We'll probably be done with it pretty soon. Just bear with us for a little. And we have thousands of customers in many countries around the world, including some big customers such as Microsoft, GE, Panasonic, and Charles Schwab. And how do we do that? And what is Marketo's engagement platform? In a nutshell, it's just a way to allow our customers, who are marketers of big, small, medium-sized company, how they can actually engage with their customers, have touch point with the customer at scale. And that's pretty much what Marketo engagement platform is. And with this engagement platform, it will allow our customers, who are marketers, to reduce the complexity to engage and deal with the customers seamlessly across multiple touch points and allow them to grow their revenue and customers. And at the end of the day, our customers can listen from the customer, learn what they like, and then engage with them. Now, before we start with our journey, we want to give you some terminologies first, just to make sure that we are on the same page about what we really want to do. So we'll use what we call lead quite a bit. And the lead is merely just prospective or real customers of our customers. And now, I'll give you a very, very correct example of what our application does. Right? This is a multi-tenant SaaS application. We call it the next-gen campaign processing platform. And the use case, this is a very, very simple use case of how our customers, the marketers, can actually listen, learn, and engage. Suppose they put out a form, a landing page for their lead to fill in. And if the lead does actually fill in, the marketer has many choices about what to do. One of the choices can send an email to invite that lead to attend a webinar. And suppose this lead actually does accept the invitation. Well, the marketer has a lot of choices of what to do as well. And for example, the marketer can choose to increase the score of this lead, just to indicate that, well, there's a higher chance that this lead will buy from this customer, whether it's Microsoft or GE or Charles Schwab. Now, what we call these two actions, the send webinar email and increase score, we call them real-time campaign actions. And I mentioned it's near real-time because it's fast enough, but sometimes there's a little bit latency between the action, the events, and the action itself. And these type of actions are executed in our campaign processing engine. Now, I want to actually explain a little bit about what makes up this real-time marketing campaign or Marketo campaign. Like what we talked about, right? There is an event, it's real time, it's reacting to something. So an event come in for a lead. Well, it can be one of the many, many things. We have probably 50, 60 types of events that we're listening to. It could be that a lead is created in our marketing system, our Marketo platform. It can be just what we talk about, where we send this lead an email, or we actually synchronize this lead to our CRM systems. And with that, well, the marketer can further refine the target criteria. Well, we can say, I want to only target the most influential decision makers, maybe only if you have job title equal to CXO, or maybe your industry is high tech, or maybe just the people living in France. And last but not least, well, the campaign must have some action. We already heard a couple of them. Sending email is an action. Also, increase the score is an action. Or add the lead into a marketing list in our system is also an action. We have about 40 different types of actions that we can execute. Now with that, Jane is going to talk a little about our legacy challenges.
So thanks, George. I will briefly talk about our legacy system and the problem we experienced with it, and that's how it drives us to the reactive mode. So our legacy system is built on PHP and Symfony framework. It was designed many years ago, and by design, we split our customer instances into groups, and those are allocated to physical machines as a group. So as this chart, you can see one group actually have a few clusters of dispatchers and PHP processes. The dispatcher basically listens to the task comes in, and it sends command to the PHP processes. This is exactly a kind of a task-driven system, and eventually output to some external system like databases or some external endpoints. So a few years ago, we already noticed that there are some limitations or issues with our legacy system. First of all, it was designed for like customer instances with about 1 million leads. And later on, we noticed our customers are actually growing fast. A lot of them have more than 1 million leads, and some of them have close to 100 million leads. This leads to a no longer real-time process, and sometimes we see a quite long queue of backlog items. And also we noticed we need more cluster management. It's current in the legacy system, it's hard to expand our clusters because it's bound to physical machine power. And resource sharing is possible within the group of customers, but it's impossible between groups. And also, there's very little visibility on the cluster healthiness and performance. So with all this, it kind of drives the decision that we have to build a next generation platform that can overcome all those concerns and issues. When we start thinking about our next generation platform, we need to know what are those requirements are, right? Because we know the concerns of the legacy, we came down a list of requirements. First of all, this whole thing, we're trying to solve the scalability issue because our customer is growing fast. And also our customer base are growing. So we want to be able to handle more customers and bigger customers. And fairness is important between customers. Every customer should get at least the machine power that they paid for. At the same time, we want to maintain elasticity. So when they have huge or heavy load comes in all of a sudden, we should be able to scale up their processing power if they want to pay for that. And due to our business need, we want to maintain the order of campaign actions on per lead basis. Fault tolerance and failure recovery is for sure a requirement for any distributed system. So I'm not going to talk about that too much. Back pressure handling is an important factor for distributed system. If you listen to the previous talks, I think a lot of talk mentioned back pressure handling. We want to make sure when heavy load comes in, if we cannot process them in real time, at least they go to a queue, all the tasks are not lost. So last but not the least, this whole thing, we're trying to aiming for higher throughput, right? That's how we can make this whole 1-year project worse. So we're aiming for 50 times or more throughput. So that starts our journey.
Yep. So basically, you can see that this is not very easy to do, right? We didn't know too much about reactive system. We didn't know too much about Akka. And we are about to replace a system that is running 24/7 for thousands of customers. And we are chartered to replace the system within a year, or start replacing this within a year. And in order to do that, we had to go through a few very, very carefully planned stages. Well, first of all, well, we didn't start to say, hey, we will use Akka for sure, or we'll use Reactive for sure. Well, we need to convince the company, our architects, within the team, entering the management teams, as well as everyone that, well, using this exact technology is the best. Well, what we do is that, and basically the second thing is, once we have chosen a technology, well, we need to get our people ready. Well, because this is a new technology, not many people actually know about it, and we have to make sure our developers are ready to go through the journey. Well, then we have to go through a detailed design stages, and also implementation, and finally, we got to roll out the system to thousands of customers to allow them to do so, and this is not an easy thing to do. So first, well, like I said, we didn't know too much about Akka, Reactive, and we actually have gone through multiple prototypes and evaluation of technologies. And it came down to a few choices, and I just want to mention two of them, Akka Cluster, and Spark Streaming. Now, we decided to use Reactive and go with Reactive for a couple of reasons. Well, one is that, well, as mentioned, we have about 40 different types of campaign actions. Some of them can execute in a few milliseconds. Some of them will actually take many seconds to complete, particularly if it's calling out to an external system. And with Akka, it's a little easier for us to deal with the very different execution times. Spark Streaming will require a little more work for us to do so. So we chose Akka and Reactive. Well, programming language, well, it's not really a big deal for us to choose either Scala or Java, but most of our team members, the existing team members, did have some experience with Scala, and it makes it a little easier to program Akka and Reactive in Scala. That's why we chose to use Scala. And after convincing everyone that this is the good technology for us to go through, and it's not an easy thing to do, because before we started this project, like I said, right, our company, nobody else and no other systems had gone reactive. And we had very little real use case of Akka in our system as well. So we've gone through a long stage of prototype, piloting, discussion with other architects, discussion with other senior engineers, and really convinced the team that this is the best way to go. And now we can go into a little bit of the architecture of how it looks like. So for those of you who attended my colleague's session yesterday, bear with us for a couple of minutes. Or maybe we can refresh your memory about how it looks like as well. Well, first of all, this is a real-time campaign system, so it means that some events must come in. Like we actually talked about in the example, if the lead sign up for a webinar, or if the lead, we send the email to a lead, well, those are events that will be generated and come into our next-gen campaign processing system. And once we have that, well, we'll go to the first component of a next-gen processing system. It is what we call as the traffic controller. When an event for a lead for our customers is coming in, well, we first chart the event by our customer's ID. For example, if it's Microsoft, this event will be charting by the Microsoft ID. If this lead is for Charles Schwab, we'll chart it by Charles Schwab's ID. And this allows us to parallel process and control the fairness as well as the order of the lead events and satisfy some of the requirements that Jane has mentioned previously. And we also first enqueue the event into an enqueuer, and this provides us with some back pressure handling capability as well. And once the controller decides that, well, this event is ready for processing, what it does is going to send to our next component of our architecture, which is the execution engine. You'll first enqueue that event into the enqueuer. We first actually shot the event again in the execution engine slightly differently. In this time, we'll shot it by not just the customer ID, not just by, hey, which customer the event is for. We'll also shot it by the lead ID as well. Each individual lead of each of our customer will have a unique identifier. This will ensure that the lead will always go to the same execution engine and ensure ordering. And once that is enqueued, the execution engine has only one simple thing to do. It will dequeue and process and execute the business process that it's supposed to do. Now, how do we scale? We will talk about it, right? This system needs to be very scalable, and we need to do a lot more. Our big customers really want to do a lot more, send a lot more emails, sync with our CRM system a lot, do a lot of processing of the marketing lead. And we need this system to be very scalable. Well, the first easy way to scale is to just add more nodes to our cluster. So suppose if a customer suddenly want to do more, or we add more customer to the existing cluster, we can just simply add more nodes to this cluster, and it will scale. We'll scale it out. But suppose, while Marketo is doing fantastic, we actually suddenly sign up thousands of new customers, bringing a lot of revenue. Well, when that happens, we can create additional cluster. And we can keep creating more and more cluster to allow us to scale out to as much as we like. When we have more and more customers, we just build more and more clusters. Well, with all that, I want to bring your attention to how we actually divide functionally our next-gen campaign processing system so that we can divide the work among our people as well as to successfully roll out the system without much of a problem. So all those technology, the architecture, the cluster, the reactive system, most of that is actually related to what we call as the campaign framework. The framework will listen to the event and then determine what business process to call. And the business process is one of those potentially 40 different type of campaign actions that we can execute. For example, send an email to a lead, increase the score, sync to our CRM system. Those are campaign actions, business processes that our marketers want to execute in a campaign. And we will refer to these two things as the campaign framework and the campaign actions. We'll talk about how we deal with them separately. Now, we have an architecture, we have a plan. We now have chosen the technology and the programming language. We have a few challenges ahead of us. And how do we resolve that, right? So, like we said, we have to replace this system within a year. We start replacing the system. This system, the legacy system, has been around for more than 10 years. We've been serving thousands of customers for more than 10 years. The code has been developed, enhanced, and maintained over 10 years. It's not an easy thing to actually replace a live system within a year. So we first need to hire more people. We want to hire the resources, empower them to do it. And second, we want to train them so that they actually know how to do reactive programming as well as Akka, as well as Scala, and be able to do both the framework and the business processes. So let's first talk about hiring. And some of you know that maybe from high tech, or particularly those from the Silicon Valley, hiring developers is not an easy thing to do. It's a very hot market. It's really difficult to hire someone to join your company. It's too much competition. Now we are slightly more fortunate. We are not a super big company, but we do have multiple offices. So I have a development team in Portland. So we are hiring in parallel in both San Mateo in California, as well as Portland in Oregon. So this allows us to enhance the chance of hiring more people so that we can build out our team. Now, we also work very closely with our HR recruiter. So for those of you who are a lead or a manager, and HR recruiter is your friend, work with them. We actually had a very, very super great recruiter that we had, the best one that I've ever worked with in my career. And she found us a ton of good people to choose from. And she's now currently not at our company, in one of the other companies, unfortunately, but so she's a great recruiter. And with these two favorable factors, we are actually able to hire and build out our team within a couple of months. and is pretty miraculous. Now, training. Like we said, well, we need to do Scala. Every developers need to do that so that we can share the code. We don't want people, some of them to use Scala, some of them to use Java. That would be really hard for people to work together. So we want to make sure that all developers are well trained. Luckily, most of the existing team members are already familiar with Scala, and because they have done some previous project in Scala. But some new team members will need to do that, learn about it, because it's really hard to hire people with good Scala experience already. So we organize, particularly with our experienced team member, and they will organize study group. They will watch the Coursera courses together, do their homework, and then compare the answers, and ensure that everyone is doing well. Now, we also provide some training class. We brought some instructor in-house, and have a couple of days of training class, just at least get some basics to many of our new team members. We also provided a lot of books. We purchased multiple copies. Some of the usual suspect. You guys have read some of that to just ensure that people are, if they need reference, they have some books to go back to. And then we need to train our people in reactive methodology and Akka as well. And this is a little harder. Now, not all the team members will need to be really strong and reactive and Akka, because most of the people who work in the framework will need that. Some of those who work on the business processes, well, they need to know a little bit, but not as much. So what we did was, well, we have our architect actually took the lead and learn about Akka, learn about reactive, and organize study groups to train the people. So at least get some people, get some basic knowledge across to the team members. It's worked very well. Books. There are multiple books. We provided enough books for our team people so that they can actually learn a little bit more about Akka and reactive as well. Now, Akka documentation is important. It's your friend. If you are starting to work on Akka, well, online material is very, very important. And Akka documentation, basically many times we found some good answers, and most of the time it works. When it doesn't work, trial and error. We have experienced many failures in some, well, not failures, but things that didn't work the way that we thought it would. And we just have to go with a different approach. And last but not least, towards the second half of the project, we probably should have done it earlier, but at least it's better late than never. We did bring in a few instructors to give our people some more training on Akka and reactive. Now with that, we are ready to go and do the real work and do the detailed design.
So here I'm going to talk a little bit about our experience on detailed design and implementation. So this is a big project, as we mentioned. So if you guys ever want to do this kind of lift and shift, hopefully this will help you a little bit. During the detailed design phase, so like we mentioned, this is a big project that we actually spent a year on it, and roughly about 10 people consistently working during this 1 year. So we split it into multiple work streams. As we mentioned, Akka is a core part for our framework. This core work stream will have to learn Akka actors, Akka messaging, the clustering, partitioning, sharding, a lot of details they need to figure out. So there's one work stream for that. We also have a common API work stream. Those engineers will build very robust and performing APIs for the other group of people who are building the campaign actions. We have, again, about 40 campaign actions. So a lot of people have to work on that. But luckily, they have the APIs, so they can only worry about the business logic. So that's how we split. And we also have some other groups like system engineers, operation team. I'm not listing all of them, but the idea is you split into small component and small work streams. And every work stream hosts their own design reviews. They have their own milestones for each work stream. And then we kind of do synchronization between work streams. So we have regular group discussions, and we keep going back to our architects for design reviews, like even smaller things, we do architecture design review to make sure this new version of the project holds the highest quality. When it comes to implementation phase, we leveraged Scrum methodology. I'm sure a lot of engineer team knows Scrum very well. I'm not advocating for Scrum, but it works fine for us. So we have 2-week sprint. For every sprint, we have sprint planning, review, which include a demo if possible, and we have sprint retrospective. And between teams, like I said, we have multiple work streams. Between teams, we have this thing called Scrum of Scrum to synchronize the progress. And don't forget about unit tests and automation tests. So while we are developing our application, we actually already developing our unit test. This is owned by developers. And our QA team got involved very early on. They started their automation early on. By the time we have our application, they have a lot of automation done already, so we can already start running automation tests. And finally, if you listen to the keynote speaker, Randy Ray, he also mentioned that incremental change. So we do incremental releases. We spread across multiple releases, and we even build a way to call legacy actions from our new generation platform. So this way, we can do incremental rollout. So some component may not be finished yet, but we can already start roll out those completed and finished testing component. This way, we can control the impact on customer better. So, talking about rollout, as any big application or big feature, rollout is actually pretty tricky work. It actually took us a lot of time to do the rollout. So we are very responsible to our customers, so we actually listed requirements for our rollout. First of all, no noticeable service interrupt for sure. You can't say that, oh, we're enabling a new feature for you, but then the function is broken. That won't work. So we do phased approach. As I mentioned before, we have many components, and we do incremental rollout. We release those components little by little. Also, we have a way to do passive testing. I'm not sure if any other engineering team doing this. So-called passive testing is a way we try to simulate our real production run, but actually the output goes to a dummy storage, and the real customer request is still processed by the existing system or so-called legacy system, and we can compare the dummy result versus the existing system result. So this way we actually pick out a lot of bugs through this way. Of course, we need to build tools for provisioning, deprovisioning. In very unfortunate case that some customer experienced problem during their, when they are enabled on new platform, we can quickly turn them back. And also build a lot of monitoring ways and alerts. There's a way we build metrics for our VM, memory, and CPU monitoring. We have Throughput Matrix. We also have a lot of alerts. I'm not listing all of them here. So this is an example of our wavefront dashboard. You may not be able to see the very detail of those, but this is a throughput matrix that we can see the in-queue amount and the dequeue amount. We can see whether we have any lag. And it can go down to each cluster level. Like George mentioned, you can introduce a lot of clusters. So you split out your customer base. Maybe some customer want their dedicated cluster, no problem. They can go their dedicated cluster. And we can go down on cluster level, and we can even filter by customer and see customer throughput. And George will talk about more rollout mechanism.
Yeah. Well, as you heard that rollout is a pretty tricky thing. It's not as easy to do, particularly for a live system. So we're going to spend a little bit of time to actually go through the process that we did. So before we start, how many of you have the experience of replacing a live running system without service interruption? Great. You can probably later on share some of your experience at the end as well. I think We're glad to hear from you what you guys went through. And it's kind of like, I mean, probably you had this experience that it's like you're flying an airplane in the middle and you want to change out the engine because you don't want to cause any system outage, but you have to move forward. So a few things that we have done that is quite useful for us. Hopefully that we will hear some of the other ideas at the end by some of the participants here as well. So first, passive and active mode. Like what Jane mentioned, well, we first try as much as we can, both the framework and each one of the campaign action, if it's possible. Well, we'll first try with the passive mode first, simulate what it actually would have done. It would be active, and then we will compare the results. Well, second, we want to monitor. We want to make sure that if there is anything wrong, we will know it before the customer know it, because if the customer know it first, then they will call support. They'll say, hey, how come you guys are causing some system outage? That's not what we would like to see. So we'll monitor very, very closely with alerts. And many times, actually most of the times, we found the bugs first before anyone noticed. Well, we could actually either fully or partially deprovision the system. Now, we haven't actually, luckily, we only needed to do a couple of times to do some large-scale deprovisioning early on when we first roll out. But since then, it's been relatively smooth. Occasionally, we might have to turn on one particular business action for some really interesting corner cases. And talking about corner cases, I'm not sure you guys have this experience, but for us, it's really interesting. We never really fully documented our feature to our customers, right? So a lot of times, it is a gray area how things will work. In our legacy system, we had a lot of bugs that become features for our customers. And our customers have been relying on those features to do their business. For example, when we send out or sync with a CRM system, and if we sync down to our system, well, if they don't give us any value, well, we'll treat it as current time, which is, you can argue whether it's right or wrong, but it's certainly not our intention. But the customer has relying on this type of behavior for so long. Another example is that when we send out an email, well, we don't encode some of the values, which is not right. Actually, it's a bug. This one is completely a bug. But customers will say, hey, I've been doing this for so long. Please don't encode it. You got to do something different. Keep the bug and not fix it. Basically, we have a lot of those. Interesting experience. So occasionally we have to turn off some of part of a system, conform with the legacy behavior, those undocumented features, and then move forward again. Now, I want to call to your attention something that we plan very carefully in order to roll out this system. On your left-hand side is a picture representing the legacy system. On your right-hand side is a picture representing the next-gen platform. At the beginning, you can see that the legacy system is fully colored with the nice purple color, our company color, as well as all the business actions listed. Well, we only list a few examples here, are all highlighted. So at the beginning of our rollout, everything is running in our legacy system and nothing is running in our next-gen platform system. And this is the beginning stage. And then let's start the rollout. Well, first, we want to stick to a small set of customers. Just like any systems, right? We cannot guarantee there will be no bugs. In fact, we can guarantee that there will be bugs. And we want to limit the exposure to as small a number of customers as possible. And we'll start the phase 0. Phase 0 is just a passive campaign framework. What it means is that, well, as you can see, the left-hand side picture, the legacy system is still fully colored and all the business actions are still fully highlighted in their text, in the names. But the right-hand side, you can see that the background, the framework, campaign framework, the outer rectangle is now lightly purple. It means that it's doing something. It's doing passive mode. It's trying to simulate what it would have done if it's real. It's listening to the same event that coming into the system as legacy system and try to determine what it would have done. And then, like what Jane mentioned, we'll store that results into a temporary storage. And regularly, we'll compare the results with the actual campaign results with the legacy system. Everything goes well, we graduate from phase 0 into phase 1. Now, phase 1, you can see that in the right-hand side. Now the outer rectangle is now fully colored in purple, and the legacy system is now not, well, it has no color, it's gray out. However, you can see in the middle of the next-gen system, nothing is highlighted. There's no business processes. As Jay mentioned, we have altered our system so that our next-gen campaign framework can actually call the business processes, the campaign actions in our legacy system. In this stage, we are only testing the next-gen campaign framework. It's fully active. The legacy campaign framework is now not active at all, and the next-gen framework is active, but it's calling back to the legacy system for all the campaign actions. Well, we actually stayed there for a while and just make sure that everything is working. Once everything went well, we went to the next phase, which is phase 2. Now, we are starting to migrate the business processes, the campaign actions to the next-gen system. What we did was that, well, we will do it in stages because each one of them represents some key business processes that our customer rely on. When I first joined Marketo, I really didn't realize that, well, marketers consider the marketing automation to be a fully important key system to their work. Anything went wrong, they will call us immediately, they will talk to our CEO, they will go to the salesperson, hey, everything is broken, they cannot do the work. And I didn't realize that when I first joined more than 6.5 years ago. And now this is a mission-critical system for our customer who are marketers. Good thing for us. So we will do that in stages to make sure that we don't break things all at once. If we do break things, we can control it, we'll fix it, we'll take care of that. So we'll do it in stages. We'll still stick with the small set of customers. So we'll first select a few campaign actions, and we will migrate them from the legacy system to the next-gen platform. So now, when the event comes in, if the event is to increase score, in this case, for example, well, it will actually execute the campaign action natively in a next-gen platform. But let's say if we are sending out email, the campaign framework in next-gen will still call back to the legacy campaign system. Now, we'll first start with a couple of those campaign actions. And once they did well, there's no problem, everything went well, then we'll go to the next. Maybe the next one is sync to CRM systems. Tried it, see what happened. Oh, suppose there was a bug. Customer process is now broken when they sync the lead to the CRM like Salesforce or Microsoft Dynamics. Well, what we did was that we would turn it off, get it back to legacy. Very seamlessly, we can easily do that one command, that back to legacy. And this has saved us numerous times for customer issues. And some of those business processes were a little harder, some of them a little easier, so some of them actually had a few more issues than we would like. And once we address the issue, for example, in this sync to CRM business process campaign action, well, we can turn it on again, get back to the next gen. If everything goes well, then we'll migrate all the campaign actions, all our 40 different campaign actions, all to the next-gen campaign processing systems. And we were ready for the next phase. Now, in this phase, we're actually starting to migrate the customers in larger numbers from the legacy campaign processing to the next-gen campaign processing. We still would like to do it in stages. Like we said, right, we really do not have, our campaign actions have many, many possibilities, a lot of conditions, thousands of possible code paths, plus 40 plus different type of actions. There are a lot of cases that, well, maybe one customer would experience, the other customer would never experience. So we still want to do it in stages to basically gradually have more and more customers into our next-gen system. So we'll start with set 1. Well, maybe about 25, 50 of them. Well, we have 11,000 of these customers to migrate. So we'll start a little smaller. Now, once everything went well, no complaints, customers happy, well, we went to the next one. For set 2, maybe this time we did 100, 150. And then we did set 3, maybe a few hundreds. And then set 4. By the end of phase 3, and we would have thousands, not all, but thousands of our customers onto the next-gen platform already. We couldn't move all of them just yet because we had a little bit more things to do. Well, in phase 4, all our new customers, well, when we sign up a new customer, someone pay Marketo to do their marketing, well, we're creating a customer instance for them in our multi-tenant system. We want this new customer to be on the next gen automatically without even going through the legacy framework, legacy campaign system. And we also want to have a point of no return. Basically, once you're on next gen, we would not be giving you the ability to go back to legacy. And this has a couple of big benefits for us. In order to support the seamless provision, deprovisioning, it meant that we would have to store some data that was required by the legacy system. If we don't have to do that, well, we can further improve the throughput of our system. The less amount of data that you store, the less time you need, and the better throughput we have. So in phase 4, by default, all new customers will have the next-gen campaign processing system. And once you're on, there's no return. You're on forever until the next-gen comes up. Now, in the final phase of our rollout, well, all the customers, all 11,000 of them, all 11,000 of Marketo customer instances will be now on the next-gen campaign processing framework and system. And we will be then able to start to phase out both the infrastructure as well as the code base of our legacy campaign system. Now, the results. After, relatively speaking, about a year in design and implementation, and about 9 months in rollout. The rollout was a relatively long process with the campaign framework, plus more than 40 different types of campaign actions, working together with a cross-functional rollout committee, including customer success people, support, engineering, QA, product management, everyone together to determine whether we are ready for the next phase. We are currently completing phase 4, so we're not completely done. We haven't actually finished phase 5, but we have finished phase 4. It means that, well, we have much lower costs of operations already. And some of you might have been to the talk by our colleagues yesterday. You saw some numbers in legacy. For the same number of customers, more or less, we don't have exact same comparison. But in legacy, we are running big physical powerful hardware servers with about 384 to 480 cores of CPU and about 384 to 768 gig of memory, serving similar number of customers. But in next gen, well, we are running in VMs only. And we are using about 32 cores, and we are using 64 gig of memory. As you can see that, not only that our system is a lot faster, a lot more powerful, a lot more scalable, we actually have lowered the cost of operations, saving the company money as soon as we can fully retire our legacy infrastructure. And at the end, thousands of happy customers and thousands more to come when we complete phase 5. And just in summary, within 2 years, development time, rollout time, we went from this monolithic, well, actually not quite monolithic, but some similar, and inflexible, relatively less performing, less scalable system, a legacy system that using powerful big servers costing a lot more money, to this very reactive, scalable, performing, lightweight systems that allow our customers to do a lot more business processes as well as lower the cost of operations. With that concludes our talk. I hope that I can give you some interesting information on your journey to go reactive.